So the idea of what we're going to do here is we're going to take this equation and we're going to graph this equation without doing a function table. All right, so for the first part here, we want to find the value of x when y equals 0. So for part A, we're going to say y equals 0. And we're going to take this and we're going to plug it in here for y. All right, so I'm going to write this equation exactly like it is, just like we did in the function tables, except I'm putting 0 in for y. Last week on the function tables, most of the time we were putting numbers in for x, right? All right, so this time I'm going to put 0 in for y. And help me out here. What is 2 times 0? That is 0, right? So if I rewrite this, I get 3x plus 0 equals 6. And what is 3x plus 0? It's just 3x, right? That plus 0 doesn't do anything, so this is really just 3x equals 6. All right, so the first thing I want to point out is we're going to use the 0 a lot because it makes things really simple for us. 0 times anything is 0. 0 plus anything is
0? No.
The same thing, right? It doesn't change anything. So by using 0, it's going to make things really easy for us. Basically, what's going to happen here when I put 0 in is this part right here just goes away. It disappears, right? Does that make sense? So this equation then just becomes 3x equals 6, and the y part goes away. All right, so we'll look at a shortcut for that later. But let's finish solving this real quick. If I want to get x by itself, what do I need to do? Divide by 3 on both sides. So we get, when the 3's cancel here, we get x equals 2. Now I want you to notice here in the directions it says write your answers as ordered pairs. Well, is this an ordered pair? No. What does an ordered pair have in it? It has 2 numbers, right? What are the 2 numbers? One of them is x, one of them is y. Which one comes first? Okay. So in this answer here, for this problem, what is x? It says it right here. It's 2, right? All right, so I'm going to put the x first. What is y? 0, because that's what we put in for y to begin with, right? So we get an x and a y, and there's your ordered pair. All right, so this is kind of like what we were doing in the function table last week, right? So we put something into the equation, and then we solved that equation and got the other variable by itself, and then we wrote it as an ordered pair. The only difference is here we're putting 0 in for y, where last week we were putting numbers in for x. Okay? So we can still write our answer as an ordered pair, and what can we do with this ordered pair? We could graph it, right? We're not going to do that yet, but we'll get there. All right, so let's do the same thing, except this time we want to find the value of y when x equals 0. All right, so for part B, we're going to start with this, with x equals 0. And so who can tell me what that equation is going to look like with x equals 0 in there? Garrett?
3 times 0 plus 2y.
Perfect. So 3 times 0 plus 2y equals 6. And just like last time, what's going to happen with this term here with the 0 in it? That's just going to disappear, because 3 times 0 is 0, and 0 plus anything is 0. So it's really just 2y equals 6. All right, so how do I solve for y? Divide by 2. And when those 2's cancel each other out, we get y equals 3. How do I write my answer as an ordered pair then?
X first.
Yeah, x comes first. So be careful on this. Be sure, this is why we write it down. What does x equal? 0. What does y equal? 3. Yeah, that would be a weird thing to say. And so we get another ordered pair, right?
Yes, sir.
So just like in the function tables last week, you get some ordered pairs. What we're going to do with them is we're going to graph them and draw a line through them. All right, now these 2 points right here are enough to figure out what that line is going to look like. So all we're going to have to do is graph these on the coordinate plane, draw a line through them, and we're done. We'll come back and we'll do that later, but I want to get a little more practice with solving the equations first. So I want you, for example 2, to do the exact same thing. So for part A, you're going to put 0 in for y and solve for x. And then part B, you're going to put 0 in for x and solve for y. Write both of your answers as ordered pairs. on the first part, we're going to say y equals 0. So we're going to have 2x minus 4 times 0 equals 12. And what's going to happen here with this term with the 0 in it? That's just going to disappear. So what we really have is 2x equals 12. And so how do I get that x by itself? Divide by 2x equals 12. So to get the x by itself, I want to get rid of that 2 by doing what, D? If you can answer my question. Divide by 2, okay. And so on the left side, when those 2's cancel, what do we get?
6.
On the left side, when the 2's cancel, what do we get? On the left side? X. All right, and then on the right side, 12 divided by 2 is 6. Now, I'm not going to leave my answer like that. It's not going to be x equals 6, but I want an ordered pair. So what's the ordered pair going to be?
0,
So x is 6, so we'll put that first. Y is 0, we'll put that second. Be sure you put your parentheses there, and you've got your ordered pair, something that we can plot on the coordinate plane. All right, over on the other side, we're going to start with x equals 0. This is for part B. So x equals 0. So we're going to have 2 times 0 minus 4y equals 12. Now, on this one, be really careful. The part with the 0 is going to drop out, but that negative doesn't go with it. What does that negative go with? That goes with the 4y, right? So make sure that when you get rid of this 0 term here, don't get rid of that negative with it. All right, so we have negative 4y equals 12. So what do I do to get y by itself? Divide by negative 4. And those negative 4's cancel each other out. What does that leave? Equals negative 3. All right, so when we write the ordered pair, what is x going to be? 0. Y is negative 3. All right, so again, we've got two ordered pairs that go with this equation. And assuming that equation gives us a straight line, we can just plot these two. And once we plot them, we can draw a line through them, and we've got our graph. Does that make sense? All right. Before we start doing that, I want to talk a little bit about intercepts, something called intercepts, because this is actually what we're finding here. Does anybody know in math what the term intercept means?
Where the line intercepts with the x-axis?
Yeah, the x-axis and the y-axis. Actually, for both of them. All right, so the intercepts for a line, I'll show you an example here. This is the example that's on your sheet. The intercepts are exactly what Garrett just said. It's where the line crosses an axis. All right, so there's two of them. The line crosses one of the axes here, and it crosses the other one here. So the first thing I want you to do for this example is just circle those 2 points. All right, we want to identify those. All right, so there's two things that I want you to do with these. First of all, I want you to give me the coordinates of them. So who can tell me what are the coordinates of this one right here? Amir? 0, 1. All right, so we've got the point 0, 1. And which intercept is that? Is that the y-intercept or the x-intercept?
The y-intercept.
Why is that the y-intercept? Because it's where it crosses the y-axis, exactly. So this axis right here is the y-axis, so where it crosses the y-axis is called the y-intercept. So I'm going to label that, and I would like you to do the same in your notes. You can abbreviate intercept with INT, so the y-intercept. I want you to notice that when we get the y-intercept, the y value is the number where it crosses the y-axis, right? So the line crosses the y-axis at 1, so that's our y value. The other number is always going to be 0. So if we're doing a y-intercept, we're going to have a number for y, and the other number, the x, is going to be 0. If we're going to do the x-intercept, we're going to have a number for x, and the y is going to be, what do you think? 0. Yeah. So when we get the y-intercept, the x is 0. When we get the x-intercept, the y is 0. All right, so this is the x-intercept, right? You guys agree with that?
Yes.
So that's the x-intercept. I'll label that here. And the x-intercept is going to be what? What are the coordinates?
2, 0.
2, 0. So notice that the 2, the x value is where it crosses the x-axis, and the y value is 0 because it's not. We don't go up or down on the y-axis to get to that point. It's just straight over. That's a really important idea, that when we're getting intercepts, the either the x or the y will always be 0. All right, now I want you to look at the first 2 examples we did today, and what do you notice about all those ordered pairs? They're all intercepts, right? Because they all have a 0 in there. All right, so every one of the ones that we got when we plug 0 in for x and y, those are all going to be intercepts because we have zeros in there. All right, so that's going to make graphing these things really easy. I want you to go ahead and do the same thing. Label the x-intercept and the y-intercept on examples 4 and 5 real quick. If we're looking for the y-intercept, we're looking for where it crosses the y-axis, right? So at what number does it cross the y-axis? Okay, and is that 3, since it's y-intercept, is that 3 going to be the x or the y value?
Y.
That's the y value. And what's the x value going to be? 0. All right, so this is where it crosses the y-axis, so we call that the y-intercept, and that's going to be at 0, 3. Does that make sense?
Yeah.
All right, so where does the line cross the x-axis? Tori? What number? What's that? So the line's crossing the x-axis at -2, and since it's crossing the x-axis at -2, that's going to be our x value. What's our y value going to be, Tori? That'll be 0. And that is going to be our x-intercept because it's where it's crossing the x-axis. Does that make sense? All right, in the next example, which one is this? Is that the x-intercept or the y-intercept?
X-intercept.
That's the x-intercept because it's crossing the y-axis. So the x value is going to be what? 1, and the y value is 0. All right, this one here is the other one. That's the y-intercept, right? And the y value where it crosses the y-axis is? The y value is -3, and the x value is 0. So what we're doing here is we're taking the graph of a line. We have a picture of a line, and we're just looking at where it crosses an axis. All right, now, we could also say, since we know that the y value is always going to be 0 for an x-intercept, we could just say that the x-intercept is 1. We wouldn't necessarily have to say that it's at the point 1, 0, because we know that the y value is going to be 0 if it's the x-intercept. So we could just say the x-intercept is 1, and we know it's crossing the x-axis at 1. Or we could say that the y-intercept is -3, and we know it's crossing the y-axis at -3. All right, so a couple things real quick before we move on. The intercepts are where a line crosses what? An axis. All right, so that's going to be your first blank there. Intercept is where a line crosses an axis. The x-intercept is where the line crosses the x-axis. And the y-intercept is where the line crosses the y-axis. Exactly. Pretty easy, right? All right, so now what we're going to do is we're going to do this backwards. Instead of me giving you a picture of the line, I'm going to give you the intercepts and you draw a picture of the line. All right, so we'll do the first one together and then I'll have you do the next couple on your own. First thing I want you to notice is that your graph is not the same size as mine. Mine goes all the way up to 10 on the x-axis and the y-axis. Yours only goes up to like 6 on the x and 8 on the y. So your picture is going to look a little different, but it should be right still. All right, so first thing, let's get an idea of where these points are going to be. So the x-intercept is 3. Where is that point going to be? What are the coordinates of the point for an x-intercept of 3? What's the x-coordinate going to be? 3. What's the y-coordinate going to be? 0, right? No. So we're just doing the x-intercept right now. We're not going to put these together to make one point, but these are going to be 2 different points. So if we say the x-intercept is 3, that's telling us that it's going to go through the point at 3, 0. Because this point here is where 3 is on the x-axis. It's going to be right here, right? You guys agree with that? So what I'm going to do is put a point right there. That's the point 3, 0. Then for the y-intercept, we're going to do the same thing, except that -4 is the...
First, you want -4 and 0.
It's not -4, 0. It's the y-intercept, so negative 4 is the y-coordinate, which is second, and that means the x-coordinate is going to be first. And so that means we go to negative 4 on the y-axis, which means we go down 4, right? So we go down 4 and we get our point right here. And so we have 2 points. Now, last week and the week before when we graphed lines, we usually had more than 2 points. We're just going to use 2 points for this because there's only 2 intercepts, right? So get out your ID, use the edge of your folder, use something nice and straight. Draw a line that goes through the 2 points. Don't stop at the points, but go through it. And then what do we do to show these are going to keep going? Yeah, put arrows on the end. Okay, one other thing I want you to do. This example is going to go on the same graph as the next 2 examples, so I want to label this line. This is line A, so we're going to just put an A near one end of the line so we know which line it is. All right, so go ahead and do the same thing for the next 2. So for line B, we're going to have an x-intercept of negative 6, a y-intercept of positive 6. And line C is going to have an x-intercept of negative 3 and a y-intercept of negative 8. For this example, we have a y-intercept of negative 6. X-intercept of negative 6. So the negative 6 is going to be the x-intercept. So it's going to be the x-coordinate. And then the y is going to be 0. And then for the y-intercept, the 6 is going to be the x or y? Y. So then 0 is going to be the x. So graphing these then, where is negative 6, 0? Which way do we go? Left 6. All right, and on your coordinate plane, it's going to be all the way over at the edge. And then 0, 6 is going to be which way? Up 6, which is going to be closer to the top on yours. And so you should get a line that looks something like this. And don't forget to label it. This one is line B, so put a B somewhere next to the line there. All right, everybody good with that one? Okay. And then for this one, we have an x-intercept of negative 3, so the negative 3 is going to be the x or y? X. And y is 0. Y-intercept is negative 8, so the negative 8 is going to be the y, and x is 0. All right, so negative 3, 0, that's on the x-axis, that's going to be over here, right?
Yeah.
Correct? Left 3? Probably shouldn't say right because we're going to the left. And then 0, negative 8 on your graph is going to be all the way at the bottom, but on mine it's not quite there, but it's close. And we'll draw our line through those 2 points, make sure it's nice and straight. I will be checking to make sure your lines are straight, so make sure you use a straight edge, and don't forget to label that line C. So you should have an A, B, and C next to your line so that it's easy to tell which one's which. So then the last thing we're going to do is we're going to take what we did at the beginning with the equations to get the intercepts so that we can graph them like we did here. So we're going to put this together with what we were doing at the beginning. All right. First of all, you're going to need as much room as you can. So write this equation as high as you can on example 9. Just write it all the way up at the top. And we're going to do the same thing we did at the beginning. We're going to solve 2 equations. So what I would recommend doing is just draw a line going down to separate and give yourself room for each. All right. I'll do this first one with you, and then I'm going to ask you to do the second one on your own. All right. So for this first one, you guys tell me, do we want to start with x equals 0 or y equals 0? It really doesn't matter.
What?
Y?
X.
I heard y's first. Sorry. If you do x first, that's fine. So we're going to start with y equals 0. Like I said, it doesn't matter. You can start with x equals 0. We're always going to use 0 because 0 is easy to work with and it gives us the intercepts, right? So when we put 0 in for y here, what's this equation going to look like? Somebody read it for me. Perfect. Thanks, D. All right. And don't forget, this part here with the 0 is going to do what? That just disappears, right? Okay, so what we really have is negative 4x equals 24. So how do I get that x by itself?
Divide both sides by negative
Divide by negative 4, good. So divided by negative 4 cancels out my 4's, leaves x equals negative 6. Now, let's write that as an ordered pair. Let me ask this, though, before I even write the ordered pair. Is this going to be an x-intercept or a y-intercept?
X.
How do we know it's an x-intercept?
Y is 0.
Because we're solving for x. Yeah, y is 0. We're solving for x. So that's going to be an x-intercept. So this is going to be the point, what? What's the x-coordinate going to be?
Negative 8.
Negative 6. The y-coordinate is 0. And so if we plot that point, negative 6, 0, we're going to get, on my graph, it's not all the way to the edge, but on yours it will be. All right, and then we're going to repeat it, but this time with x equals 0. So we have x equals 0. What's that equation going to look like then?
Negative 4 parentheses 0 plus 3y equals 24.
Okay, good. This time this part's going to go away, including that negative. So what do we do to get the y by itself? Divide by 3. And so the 3's cancel. That leaves y equals 8. So this time we got the x-intercept or the y-intercept? The y-intercept. Since we're solving for y here, it's the y-intercept. And so we have x equals 0, y equals 8. And the point 0, 8 is going to be up 8, which on yours is going to be at the very top. And you get a line that looks like this. Don't forget your arrows. This time you don't need to label it because it's the only line that's going to be on that coordinate plane, right? Now, this replaces what we were doing last week. Remember, last week we used a function table to show our work, which is pretty much the same thing we're doing here, except we only have to find these 2 points now. We're just looking for the 2 intercepts, and that's enough to figure out what that line's going to look like. On the next example, in this example here, I want you to do the same thing. So start by saying that x equals 0 or y equals 0, doesn't matter which one. Write an ordered pair for it. That's going to give you one of your intercepts. And then do the opposite one, and that'll give you the other one. And graph them, draw the line, draw your arrows, see what it looks like.
My best guess where it is.
All right, so the coordinate plane that I gave you is not big enough. So you'll have to go off the grid a little bit. For your y-intercept, when you let x equals 0, you end up getting y equals 2. So you have the ordered pair 0, 2, which is going to be up 2 from the origin. And then your x-intercept, when y equals 0, you get x equals 10. So you get 10, 0. Now, on my coordinate plane, I can fit it on there. On yours, you'll have to you can make a couple extra marks and try to guess about where it would be. Make your best guess. It doesn't have to be perfect. That's my fault. And then draw your line through those 2 points. Be sure, again, that you go past the points and then put arrows to show that that's going to keep going on and on and on.